In this video, we're going to be looking at relationships about ratios within and between similar triangles. The first thing we want to do is we want to check and see in what order are our triangles similar, what side order. The first triangle they give us is ABC, and the second triangle they give us is DEF. And they tell us that in this specific order that these two triangles are similar. Therefore, we want to keep this order, and we want to say that our first and second angles are corresponding sides. So AB and DE are similar. Then we want to say that our second and third angles are going to be corresponding sides. So BC and EF. These are also similar. And finally, our first and third angles will line up as well, and they will be corresponding. So AC and DF, and these are similar. Now that we know which sides correspond to which other side between the two triangles, we can start putting these together in part A of our question. So the first one is AB to AC. We know that that is going to line up then. AB lines up or corresponds to DE, and AC corresponds to DF. If we fill in the side lengths for this, AB, we can see that that is a side length of 8. And AC is a side length of 10. DE is a side length of 12. And DF is a side length of 15. Now, in order to confirm that these sides are similar, they must be proportional. And I can see that if these are proportional, then they have the same rate. So if I divide 8 over 10 by 2, I would get 4/5. And if I divide 12 over 15, each by 3, I would get again 4/5. So I know that these side lengths are proportional or similar. I can do this again with AB to BC, AC to BC, following the same process. The second part of our question, we're asked to choose the correct statement about the answers to part A. And we can see that they've asked us for 4 possible answers. In each pair of proportions, the lengths of the sides of ABC are the same ratio as the lengths of the sides DEF. This is because we compared them, and the sides correspond to each other. The second possibility, in each pair of proportions, the lengths of the sides are in the same ratio, and this is coincidence. Very little in math at this point is coincidence. That's your hint. In the third possible answer, in each pair of proportions, the lengths of the sides are not the same ratio, and the fourth one, in each pair of proportions, the lengths of the sides are not the same ratio. And this is always true for similar triangles. Well, when we look at these 4 answers, this is coincidence, can't be true. We were able to prove it mathematically whether or not they were proportional. In the third answer, this is because the triangles are not right triangles. Well, it doesn't matter if they're right triangles or not, as long as they are similar, meaning that their angle measures are the same and their sides are proportional. So that one automatically can't be it if they are proportional. And finally, they are not the same ratio as the lengths of each other. This is always true for similar triangles, and that statement right there is false. That this is always true for similar triangles means that they are proportional. So in each one of these, the only logical answer that you're going to need to know is that if they prove proportional, then they are proportional because you were able to compare them and prove mathematically. So that would be your answer.